Good afternoon, students. So we were discussing about Gauss theorem and application of Gauss theorem. One application of Gauss theorem we already have discussed, and now we are going to discuss about another application of Gauss theorem. The topic is already written on the board, as you can see. So we are going to find out the electric field intensity due to a uniformly charged infinite plane sheet by using Gauss theorem. आप लोगों को मालूम ही है कि गॉस थ्योरम अगर हमें अप्लाई करनी है देन इट इज ऑलवेज अप्लाइड ऑन अ क्लोज्ड सरफेस एंड वी ड्रॉ अ गॉसियन सरफेस. सो दिस इज हाउ वी कैन कैलकुलेट द इलेक्ट्रिक फील्ड इंटेंसिटी फॉर द सेम. सपोज वी हैव अ चार्ज थिन प्लेन शीट. दिस यू कैन इमेजिन. सपोज ये हमारे पास एक ऐसी मेटल शीट है जो पूरी तरह से पॉजिटिवली चार्ज. हियर आल्सो देयर आर अ लॉट ऑफ पॉजिटिव चार्ज and on the back side also there is a lot of positive charge. तो अब इस पॉजिटिव चार्ज के कारण क्या होने वाला है? इलेक्ट्रिक फील्ड बनेगा ऑब्वियसली, और उसकी डायरेक्शन क्या होगी? नॉर्मली आउटवर्ड. यस और नो? ऑब्वियसली द डायरेक्शन ऑफ इलेक्ट्रिक फील्ड विल बी नॉर्मली आउटवर्ड. सो दिस इज हाउ द इलेक्ट्रिक फील्ड विल बी क्रिएटेड फ्रॉम दिस साइड and electric field will be created even from the this side. So this is how you can imagine that we have kept one sheet, and for this we are going to calculate the electric field. That electric field will be uniformly distributed on both the sides, even on the right side as well as on the left side. So the picture is very clear to you. So this is that particular sheet, and for this sheet we have to calculate the electric field by using Gauss law. So we have to draw a Gaussian surface, and students, this particular cylinder which you are able to see is actually the Gaussian surface which I have drawn. And when I will draw this Gaussian surface, then it should allow the following properties. That Gaussian surface should have the following properties. It is always closed. Obviously this cylinder is a closed surface. Each should be symmetrical. So देखिए सिलेंडर बनाने से कितना ज्यादा बेनिफिट हुआ. इलेक्ट्रिक फील्ड हमेशा सिमेट्रिकल रहेगा इस सिलेंडर के लिए. देखिए या तो इलेक्ट्रिक फील्ड जो होगा, इलेक्ट्रिक फील्ड डायरेक्शन इज दिस मच, ओके. तो इलेक्ट्रिक फील्ड और सरफेस की जो डायरेक्शन होगी या तो वो सेम होगी, मींस एंगल जो होगा वो 0 डिग्री होगा, या फिर आप देखिए अगर हम उस सिलेंडर के कर्व की बात करें, कर्व सरफेस की, तो एरिया वेक्टर की डायरेक्शन क्या होगी? डाउनवर्ड, परपेंडिकुलर टू दिस, सो डाउनवर्ड. तो इलेक्ट्रिक फील्ड की डायरेक्शन राइट साइड और एरिया वेक्टर डाउनवर्ड. सो व्हाट इज द एंगल? 90. और यही हमको चाहिए कि एंगल जो है या तो वो 0 रहे या फिर 90 डिग्री रहे. सो दैट इज इट. नाउ वी हैव डिवाइडेड दिस गॉसियन सरफेस इनटू 3 पार्ट्स, जो हमें करना भी पड़ेगा सिमेट्री के लिए. सो वन सरफेस इज रिटन एज S1, another surface S2, another surface S3. तो अगर आप S1 के लिए देखिए इलेक्ट्रिक फील्ड और एरिया वेक्टर दोनों की डायरेक्शन सेम है, सो एंगल इज 0. हियर आल्सो फॉर S3 द एंगल बिटवीन द एरिया वेक्टर एंड इलेक्ट्रिक फील्ड इज 0 बिकॉज़ बोथ आर पैरेलल. एंड फॉर द सरफेस S2 द एंगल इज 90 डिग्री. Now students, this is what I have written on the theory. Consider a thin infinite plane sheet. You understood this? Okay, of charge density sigma. What is this charge density? In the previous we already have studied about linear charge density. Now we are going to discuss about surface charge density. So suppose for area A, आप ध्यान से देखिएगा, the charge distributed is Q. For area A, the charge distributed is Q. Then for unit area, how much charge is distributed? Q upon A. Okay, and that is known as surface charge density, and this is not denoted by S, this is denoted by sigma. So sigma is equal to Q upon A. Charge distributed per unit area is known as surface charge density. So that is clear to you. Now what will be the value of Q here? You do cross multiplication and you will get Q is equal to sigma into A. Now students, let us apply the Gauss law. And what is Gauss law? We already have studied that closed integral of E dot ds is equal to 1 upon epsilon naught times the charge enclosed. So what is the value of Q here? So we can substitute the value Q into A, or sigma into A or sigma into S. In few books you will find A, in few books you will find S. So don't be confused with it. I have considered here S. So you may also consider, because A is the area. You can consider it A as well, S as well. We have considered it S in the derivation. So here as well I am going to consider it S. So what we will get? Sigma into S. So total charge is sigma into S divided by epsilon naught. Now apply the Gauss law. Gauss law is applicable on the closed integral. So already we have divided this into 3 surfaces. तो यहाँ पे जो हमें इंटीग्रेशन करना होगा वो इंटीग्रेशन बाय पार्ट करना पड़ेगा. So that is why I have broken it into 3 parts: E dot ds, E dot ds, E dot ds. And that is for surface 1, surface 2, surface 3. अब देखिए surface 1 और 3 की कहानी तो एक जैसी है. Both are parallel to the electric field. So angle between E and ds is 0 degree. And but for surface S2, ऐसा कोई भी surface यहाँ पर देखिए जो कर्व सरफेस में होगा, what will be the angle between area and electric field? The angle between area and electric field is going to be equal to 90 degree. Yes, and because of this will give 0. How this will give 0? Because EDS cos 90. यहाँ पे हमें E और DS का डॉट प्रोडक्ट करना है. Theta is 90 degree for surface S2. So you will get 0. So because of this, there will not be any electric field created due to surface S2. अब अगर हमें क्या करना होगा? टोटल निकालना होगा यहाँ पर. So see, the flux will be EDS due to S1 plus due to S2 is 0 plus E due to S2 is equal to Q upon epsilon naught. Why Q upon epsilon naught? Because of Gauss law. Now, the integration of ds, the integration of a small element will give the total surface area. So you will get Es. In the similar way here also you will get Es is equal to Q upon epsilon naught by Gauss law. Es plus Es becomes 2Es is equal to Q upon epsilon naught. Now substitute the value of Q. What is the value of Q? Q is equal to sigma into S divided by epsilon naught. But you will get the value of E, S and S gets cancelled out. You will get sigma upon 2 epsilon naught. So this is the electric field created by a thin plate sheet. I hope you understood.